Hello everyone, it's indeed inspiring to see you back again, and you are watching machine learning tutorials. This is the first tutorial and it is going to be very informative, and so please be with me. Let's continue. The agenda would be, we'll be starting with learning. What is learning? What is needed for learning? What is the definition of machine learning? Evolution of machine learning and learning types. So this short agenda we will be covering today. Let's begin. What is learning? Think, how do you learn and what do you learn? So learning is basically acquiring some knowledge or acquiring some skill set. And how do we do that? We basically read some books, we watch some videos, or we sit in a classroom and we listen to the teacher. Okay, so in all these activities, what we are doing, we are acquiring some skill sets or knowledge. So technically speaking, the definition says that acquisition of knowledge or skills through study, experience, or being taught. This is learning in human beings. And we are something trying similar way with machines as well. Let's try to understand what do we require for learning purpose. Yes, you have got it right. We require data. Data is the only thing we require. If you see, if you're sitting in a classroom, what do you need? What do you need, or what you are getting there? You are getting information. What is information? Information is data only. You are storing somewhere. Okay, in the mind, there are stacks. You are storing the data in the stacks in the mind. Okay, so data can be of different formats. It can be information, it can be historical data, it can be log data, it can be sensor, customer data. So different formats of data can be there, but that data is required for learning purpose. Now let's talk about machines. So what do a machine require? Even machine requires data. The way as a human being we experience a place, so we learn from that place. Why? Because we are observing. What is observation? Observation is basically capturing data into the mind, and the data is tagged over one over the other. Okay, the information is tagged. So similar way, we need to pass the data, we need to provide the data to the machine so that machine can learn. This is very simple architecture. Even if you are a very beginner, just have a look at it. So data is getting input to the machine, machine learns from the data. So who is actually learning? So there is a component inside machine learning, we call it as model. So the model is learning from the data. So once the model is learned, okay, so once the model is learned to with sufficient amount of information or data, then we can pass a new input to the model and model can do predictions. Okay, so these predictions we perform predictions for classification purpose, for grouping purpose, for outliers, so many things we do with the predictions. So this is very basic definition of what machine learning is. Let's go ahead and understand more about it. So now we will take definition of machine learning. So here you can see that machine learning is a branch of artificial intelligence based on the idea that systems can learn from data. The primary idea is system, that is machine, can learn from data and then identify patterns. The way we are able to identify some designs and patterns, machines should also be able to identify patterns and make decisions with minimal human intervention. Therefore, we will call it as learning. Machine is learning. Otherwise, if we as a human, we need to intervene, then machine is not learning. So I'm reiterating, it is a branch of artificial intelligence. We see so many products around us which are based on artificial intelligence, and we'll talk some more about it in the later slides. Let's move ahead and try to understand how this evolved. I'm just putting it into two steps. So earlier it was just complex calculations. So if you have to do complex calculations, so for human beings it was difficult, it was consuming time. So for complex calculations we designed machines. Okay, so they are simply calculators. But the step two was that create a set of instructions that would allow the computer to learn from experiences. Okay, and after learning, create a set of rules, and by these rules it can perform classifications and predictions. This is what as a human we also do. Let's say if I talk with a new person, the person is stranger. So as soon as I start talking to him, my mind decides whether to continue talking or stop talking. So what I'm doing, I'm classifying, okay, and choosing one. So I'm classifying talk or not talk, and I'm deciding one of them, okay, based upon my past experiences, that how other people talk. Does that person talks with me in a humble and polite manner, I may continue. If the person is rude, I may stop, and I may continue with my work. Okay, so this is what machine should be able to do. Let's go ahead and try to see some examples. So these are some examples. The heavily hyped self-driving car of Google. So this is an excellent example of machine learning and artificial intelligence. Then another domain we have is fraud detection. So machine learning help us in patterns of fraudulent transactions. So it identifies that some fraudulent transaction is going to happen or not. That is one thing. Second thing is that it also prevents, it triggers some actions, okay, the way we design that algorithm. So another important area. Next area is recommendation systems. We are very much untouched by Amazon recommendations, Netflix recommendations, and we have so many online platforms which recommends us a lot of things, and based on which we can decide. It becomes easy to make decisions for human beings as well because of the recommendation systems. And the last one I have put here is very important, that knowing what customers are saying about you on Twitter. So machine learning combined with linguistic rule creation help us to understand that what customers are actually trying to tell about us. Let us move ahead and try to understand now learning types. Here the first type is supervised learning, second is unsupervised, and third is reinforcement learning. We'll begin with the supervised learning. Here in the diagram you can see that some supervisors is there. Okay, I will explain you what is supervised learning. Let me take you through some exercise. So here is an exercise. Please focus on this image, and you can see these are the tropical fruits, and have a look at the fruit and the label. I have given banana, so mango. Okay, the fruit is here and the label is here. Wig, the fruit is here and the label is here. Okay, so learn from this image. Okay, you might be thinking this is first standard session or what, but you learn from this. This is really the simplest way to understand what is supervised learning. Let me take you to the next slide. I hope you have learned from this particular chart, and let me now ask you, what is this first fruit, what is the second one, and what is this third one? I know you have answered it right. These are grapes, these are bananas, and this is an apple. How did you do that? You had two things here. The first thing was the picture, and the picture, this banana picture, this is input, and the banana written is called as label. So you have input as well as output. So the image we call it as input, and the written text we call it as output. Okay, so it can be called as output or it can be called as a label. We call it as a label as well. Okay, so these are the two things we can call them as. So all the images are input and output pairs. So what does a supervised learning do? Supervised learning helps you, and at the same time helps machine to with the data which has got input and output. And now here you can see that we have only input. So this is a new data. This is new data. It does not have labels, but we are able to make predictions because we already have label data and we have learned from it. So let's go to the definition of supervised learning. Supervised learning is machine learning task of learning a function. Okay, learning a function that maps input and output based on example input output pairs. Now I think you can recall these are the example input output pairs. Input, the picture is input, output pairs. So from the pictures we extract the features, the color, the shape, the size. Okay, and we have the label for it. So this algorithm is mapping algorithm. Okay, there's a function, mapping function, which is mapping the input features with the output. And this is how supervised learning works. Now, let me tell you unsupervised learning, which will make it more clear. So here we have X and Y. X is the input features and Y is the output. Both are present and there is a function which is mapping them. And now let us go to unsupervised learning. Have a focused view of this particular image and try to identify all the features from this image. Can you see labels here? The way we have labels here in this tropical fruits, can you see labels here as well? No, the labels are not present. This is the difference between supervised and unsupervised. It is only having X. It is only having input features. It is not having Y. It is not having the labels. Now also you can do something with it. I will ask you to group them. Group these features into two groups. How can you do that? It is very much possible to do that. And let me tell you how it is possible. You can group them on the base of color. And let me show you. So you have grouped it. So here we have cluster 0, cluster 1, cluster 0, cluster 1. So all those which are having white color, they are cluster 0, and the alternative color, they are cluster 1. So this is how you can group them. And now if I give you a new data, so new data, you can easily see that this is white. So what was white? White is cluster 0. So you can classify, you can cluster as group it like cluster 0. And the second one is having the other color, that is greenish or bluish color, and it is having cluster 1. So this is how unsupervised learning works. Okay, let me take you to the definition of unsupervised learning. Unsupervised learning is a type of machine learning that looks previously undetected pattern. Understand? Undetected patterns in the data with no pre-existing labels. So it proves here there are no labels. So we actually try to group them and give them some labels. So these are not labels, these are called as clusters or groups, group numbers we have given it to them. Okay, and the new data set which is coming to us, we will also group them out of these groups which are available to us. Okay, so this is called as unsupervised way of learning. Second, one of the most powerful way of learning if we don't have the Y output or target present. Now then another type of learning is called as reinforcement learning, and this is having no data itself. So if you see the supervised and unsupervised, they have at least data, but this is having no data at the beginning. Look at this this dog. This is a pet, and it is trying to catch the ball, but the dog is not at all aware that whether it needs to catch up the ball, throw the ball, or miss it. There is absolutely no idea, no data, no information. But the objective is the dog should be able to catch up the ball. So how to do that? So what we will do, we will apply one strategy. Dog doesn't understand Hindi, English, or any other language. So what to do? We can basically do one thing. Just throw the ball to the dog, and if it is able to catch up the ball, offer him some food. And if it is missing it out, don't talk to the dog for 5 minutes. So dog will understand, if I'm missing it out, what is happening? I am losing 5 minutes discussion, or I'm not able to talk with the owner or the instructor. And if I catch it, I can interact with the instructor, as well as instructor gives me something to eat. So dog understands that I need to catch it up. So this is how dog is able to understand and achieve the objective. So the ball, the rest of the things, the instructor, everything to the dog is environment. The dog itself is the agent, and the action dog takes, that is called as an action. And dog is standing, that is called as one state. Dog is catching the ball, that is another state. Dog is missing the ball, that is another state. So let me help you with these terminologies. So look at this place. So here the dog is agent, and agent performs some action. Action is going to the environment, and because if dog is performing an action, so dog was in one state and dog is immediately getting into another state. If you're not getting this, don't worry, I have a separate video, I will put it in the link, and you can have a look at it. So the state is getting changed. So after every action, dog is either getting a penalty by the instructor or getting a reward. So this is how dog is learning after each action. Dog is optimizing the strategy after each action. Let me iterate the steps for you. So first step is observation of the environment. So dog is observing the environment. Second is deciding how to act. So initially dog was not aware, so dog did not catch up the ball, and later on so acted accordingly. Okay, after that, receiving a reward or penalty. So dog received a penalty, the instructor did not speak with him for some time, and then learning from the experiences. And dogs thought that the instructor is not talking with me, so I should do something else. And iterate until optimal strategy is found. Then dog tried to catch up the ball, and after that time, then when the whole thing repeated, dog received a reward. Okay, that the instructor is talking with him. So this is how reinforcement learning works. Google Maps are best examples of reinforcement learning. Now, let me conclude this particular tutorial by reiterating Thomas H. Davenport, analytical thought leader. So he says that humans can typically create 1 or 2 good models a week. Machine learning can create thousands of models a week. I think this excites you to learn more on machine learning. So please do like, subscribe, and share, and keep watching. Please wait for the next video. Thank you.